This is a BLDC motor checker. You can check with this BLC motor Hall sensors and the motor windings, and also you can connect with the controller. As you can see here, this is the controller. You can see here, this one the controller which is coming with the hoverboard or EV motors, and there is different types like this also coming. This is also for the three-phase hoverboard or UV motor controller. This is coming about 220 watt, 300 watt, 450 watt. It depend upon the MOSFET, which MOSFET is we are using. This is we can use up to 4 to 60 volts, and this one is 42 volt, and I have also 48 volts. So like this you can controller, but our aim is today this to how to check this one, if the Hall sensors are damaged or motor winding is correct or not correct. Here I connect this motor Hall sensors. This is connected with the, this is the Hall sensor point for the motor, you can see here I think, and other one, this is a three-phase which is connected here. This three-phase also connected, you can see there three-phase connected. Now when I move this one, now this tester is off, and when I move, see it, this three is for the motors. It is light is moving, you can see some light is there, so is depend upon when it is moving, it is generating the power. Now you can see this only two lights are generating, third light is not generating because third cable is for the test purpose. I disconnect. Now I connect the third cable, and now I will move. Now you can see all three lights are on. Now this by mistake green is disconnected, and you see the green light are not on. Now I will connect all. This is because this jumpers is not same matching. Now all three connectors, you can see now all three are on, but you didn't see the light for the Hall sensor. Now inside it 12 volt power supply, and when I connect this one, you can see here only one light is on. This means this Hall sensor is on the front, and when I move, you can see these lights are moving. This is due to Hall sensor effect. This Hall sensor, when it's coming to in front of the magnet, so it is reflecting and power is generating, and your LED is on. This is a main power supply, and also you can check with the throttle and this one here. This is the for the controllers, controller motor three-phase and Hall sensor. Then in other video I will show you. To know only this I want to show you. Now I will show you three-phase motor. Here you can see I have another this also for the BLC motor, this three-phase for the motor, and this is the power supply. This is for the potentiometer, and this is very small, and because this voltage also very less and the ampere also very less, so you cannot drive the big motor with this one. This is only for the small motors. And this one is hoverboard three-phase BLDC motor. You can see here it is having 30 magnet and 27 coils, and this here you can see this is the Hall sensor, three Hall sensor. This rotation is not possible with the one hand because its top cover is removed. What actually top cover is doing, it is keep it in the balance. Now it is one side, it is due to magnet, it is touching, that's why I cannot move this one. If you move this one, and then you can see here it is moving freely, and this 30 magnet I mark, this is 15 pole pair it is called, and 27 coils, and there is you can see there is difference. Magnet is 30 and pole pair is 15. That I will tell you what is the reason for that one. And here you can see this is the Hall sensor point. This last red and this black is power supply, remaining 3 for the Hall sensors, and 3 this HB1, HB2, HB3. These are the 3 phases, and this is 42 volt motor. And why this EV BLDC motor reason of poles and coins are not equal is different. Actually, primary is it is reducing the cogging torque and improve the efficiency. Fractionation slot constructed this windings. This is called FCSW. If the number of magnet and the coils equal, the magnet is not 27 and coils also 27, is very every single magnet would align in the same time with the magnet, so it will create a strong magnetic locking effect and making the motor feel notchy or bumpy when turning. By this different 30 magnets and 20 coils, as the few magnet align with the teeth at any given moment, this smooth the rotation and reduce noise and make the motor much faster when it is moving, and standstill it will start from the standstill. And this because of this it is giving you high torque density. This configuration allow you concentration winding where each coil wrapped around a single stator of the teeth rather than overlapping multiple teeth. This saves copper reduction and size of the motor and increase the torque. This is mainly function to increase the torque. Then and this short and turns because the coil doesn't overlap the dead part of the wire. The loop at the end is much shorter. This reduces the electrical resistance and heat, making the motor more efficient. And if you see these 3 Hall sensors, these are used to detect the position of the rotor, tell the controller which coil to magnetize. There is 27 coils, so each time this pair 27 9 coils are magnetized each time. So this wire together into 3 phase 9 coils per phase. The controller only need to know where the magnet pole and relative to 3 phases. A 27 to 30 ratio combination provide a very high winding factor around 0.945, meaning the electronic switching commutation is exactly effective and converting electrical current into mechanical movement. And for a 3-phase motor to run smoothly, the number of slots must be multiple 3, which is 27. The relationship on 27 slot and 30 poles is near match that balance magnetic forces. This prevent the rotor from being pulled to one side, which would otherwise wear out the bearing quickly. So thank you for watching. This is today information about the BLDC motor and the tester. Next video I will show you tester attached with the controller and the motor. Then I will explain the next. Thank you. Please subscribe.